today's video is going to be on the different angle relationships that we find in the triangle. And the first one we've already talked about before, and you should know it is the Triangle Sum Theorem. The Triangle Sum Theorem says that all three angles in a triangle are going to add up to 180 degrees. So this is something that we do know. We're going to look at an application and how I can use this within my triangle to solve. So the first one here, we've got this bow tie looking problem, and I have two triangles. This first triangle here on the left, I'm going to concentrate on one triangle at a time using that Triangle Sum Theorem. I've got 22 degrees, 66 degrees. So to find that missing triangle in here, all three have to add up to 180. So I do 180 minus 66 minus 22. I'm going to take both of those angles away from 180 so that I can find that missing angle, which is going to be 92. So this angle right here is 92 degrees because 66 plus 22 plus 92 is going to add up to 180. From there, I need to use old school rules back from Unit 1, vertical angles. We know vertical angles are congruent. So if this angle is 92, this angle is also going to be 92. And that's how I move from one triangle to the next. Now I've got a whole second triangle here. Now these three angles have to add up to 180. When I look over here though, a little bit different, I see that this is x and this is x. Since they have the exact same variable, the exact same expression, this is telling me that this angle is congruent to this angle. It's an isosceles triangle. So the vertex, or this angle here, is going to be 92 degrees. So I do 180 minus 92. And that's going to leave me with 88 degrees. Now each of my angles aren't 88, because if I were to do 92 plus 88, I'd be well over that 180 degree mark. I have 88 degrees left between both of those angles. But because the angles are congruent or the same, I'm going to take that 88 and I'm going to cut it in half to get 44, because I'm going to divide that equally between those two missing angles. So in this case, my missing angle x is going to be 44 degrees. We're also going to use that Triangle Sum Theorem in number 2. Again, we have all these different triangles. I'm going to look at the application of that triangle. So if I look first, I've got this triangle. And this one's a little bit more difficult because it's an overlapping triangle. So you've got to be able to visually see that. I highly suggest the use of colored pens to distinguish the different triangles. So we have our three angles. We have 47, 72, and that's going to help us find this missing angle over here, because all three have to add up to 180. So we do 180 minus 47 minus 72, and that's going to leave us with 61 degrees. So this angle right here is going to be 61 degrees. Now that's overlapping a second triangle. So I'm going to concentrate on this other triangle over here. So this triangle, we have 68 and 59. So to find this missing angle, we do the same thing. We do 180 minus 68 minus 59. To find that this missing angle here is going to be 53. So again, we're still just using that triangle sum theory that all three angles in a triangle have to add up to 180. We're getting closer. Now we had this big purple one, this big green one, but did you notice that when the purple and the green triangle overlap, they created a smaller triangle that I've outlined it here in blue? We're going to use the same idea, the Triangle Sum Theorem again. We have 53, 61. So to find this missing angle, we do 180 minus 53 minus 61 to find that that angle is going to be 66. All right, so we're almost there. We want to find the measure of angle x. We are going back to that idea that we talked about in number 1, that these are vertical angles, and vertical angles are congruent. And that's going to leave us with our final answer that the x is going to be 66 degrees. The next angle relationship that we're going to talk about is the exterior angle theorem. The exterior angle theorem says the measure of an exterior angle, so this is important, of a triangle is equal to the sum, so sum means that you're adding, the sum of the measures of the two remote interior. So that seems a little confusing. If I were to look at a triangle, the exterior angle would be right here. Here's my exterior angle. The two remote interior angles would be this angle and this angle. I used a different indicator because those are not congruent angles. Those two are the remote interior angles. Interior means inside. The remote, think about a remote island. They're the two angles off by themselves. So the exterior angle is equal to the sum of the remote interior. The way we use that theorem to solve, so the exterior angle, 8x minus 6, is equal to the sum of the remote interior. So I add the remote interior angles together. So we have 8x minus 6 is equal to 82. We add the 6 over to solve for x, and we get 88. So we find that x is going to be equal to 11. So this one wanted you to find all the missing angles. We know that x is 11. This angle is 50, this angle is 32. I can go ahead and plug 11 in. 8 times 11 minus 6. We find that this angle is going to be 82. Again, this angle has to be equal to the sum of these two. So if this is 50 and 32, and that's 82, 52 plus 32 is 82. To find this missing angle, you could either use the idea that you have a linear pair right here to do 180 minus 82 to find 98, or you can use the triangle sum theorem that gives you 180 minus 50 minus 32, which is still going to leave you with that 98 degrees. So a couple different ways you can work around finding that angle. So another exterior angle theorem. Remember, the exterior angle is equal to the sum of the remote interior angles. And it doesn't matter which one you put on the left. So last time we said the exterior angle is equal to the sum. So I can add 3x minus 5 plus, we can do the sum of the angles equal to the exterior angle. It doesn't matter which side you put things on as long as you're adding the remote interior and setting it equal to that exterior angle. When these are on the same side, we're going to combine like terms. Remember, when you're on the same side and combine like terms, you're not changing the sign. We don't change the sign and do the opposite operation until we move over to the other side. We subtract that 8 over. 6x is equal to 54. Divide by 6, and we find that x is going to be equal to 9. All right, so next, we're going to put these two ideas together, and we're looking at our diagram here, and says 3 equations can be written based on the diagram. One of them has already been written. Write the other 2 equations and a justification using the theorems we learned in class. So the first one says angle C plus angle D is 180. This is an old school rule because angles that form a linear pair add up to 180. We have other ones that we can write as well. One of them being the triangle sum theorem. So I know that in a triangle, 1, 2, 3, all 3 angles in a triangle have to equal 180. Again, that is the triangle sum theorem. Or you could write out what it means. All 3 angles in a triangle add to 180 degrees. The last one that you can write is that new one And that new one says the remote interior angles are equal to the exterior angle. So if I add the remote interior angles, it's equal to the exterior angle. And that is the exterior angle theorem. I feel like with the triangle sum theorem, a lot of times people like to write out the whole thing just because you're used to knowing that one. But for the exterior angle theorem, I would write exterior angle theorem because it's a little bit more work to remember all the details of the exterior angle theorem and to be able to write it out correctly. Okay, this is our last one. This is our last one because you can use the exterior angle theorem or you can use triangle sum and old school rules. So it's just a matter of how you want to approach this one. I'm going to go ahead and start using old school, things that to me are more intuitive. So if I'm looking right here, that's forming a straight line. That's going to be a linear pair. And if I have a linear pair, remember they add to 180. So I do 180 minus 100, which is going to make this angle right here 80 degrees. I can do the exact same thing over here. This is again a linear pair. So I do 180 minus 140, and that's going to leave me with 40 degrees. Okay, at this point, you could find x. If I use the exterior angle theorem, it says the remote interior angles are equal to the exterior angle. So I can find that x is equal to 80 plus 40 and find that x is 120 degrees. That's using your new theorem, which makes it a little bit shorter. Let's say you forgot about that, which is okay. I can use the triangle sum theorem. I have 80 and 40. So if I'm going to find this missing angle, I do 180 minus 80 minus 40, and I'm left with 60 degrees. So I use the triangle sum theorem that all three angles have to add up to 180. And then from there, I can use the linear pair relationship again to find x, because these two angles together form 180. Then I would do 180 minus 60, which is going to get me that exact same answer as 120. So it's up to you. Whichever one instinctively makes more sense, go ahead and use that one. You could use triangle sum, or it's a little bit shorter to use the exterior angle theorem. All right, that is it for today.